Once again, our most valued student, my name is Confident, and we are continuing with the calculation of Kc, and I've looked at the Kc expression. This is the paper that was written in Gauteng. That's the first video that we did. Check it out. It's video number 1, calculating Kc. You need to definitely get hold. It can help you get these 20 marks. And then we looked at the Kc, and this Kc, I think this question, I forgot where this question is from, but it's also from another province. We did the Kc here, and it was also 9 marks. And this one now involved solving for x and the quadratic equation. It was a bit long, but get hold of it. And then the next one, this one is for KZN, but before that one, in video 2, I also did this one from Eastern Cape. So I think it was Eastern Cape and Northwest or so. I think those were the two. Now this one that I'm doing is from KZN. So guys, it's very important for you to get hold of these questions. So let's look at this one. I'll try to be as fast as I can. Okay, so let's look at this. As you say, it's a prep exam, but good for your June, good for your prelims, good for the final. Consider the reaction represented by the balanced equation below. They give you that it's already balanced. Then they say initially 1 mole of that and an unknown mass of oxygen were mixed in a sealed DM3 container. Initially, I like that part. The moment they say initial means at the beginning. This is what you have of HCl, 1 mole. Unknown, we will make it X. We'll call it X mass, but we'll convert this to moles. We're mixed in a 5 DM3 container at this. And then 28.4 grams of this was what was present in the container at equilibrium. At 600 degrees Celsius, equilibrium was established, and so at equilibrium, that statement is very important. They gave us this. So guys, those values are very important. Now determine the term chemical equilibrium. Chemical equilibrium is what does it mean? Means that it means that the keyword there is to say the rate, because equilibrium is the rate of reaction. Chemical equilibrium is the rate of forward reaction is equal to the rate of reverse reaction, to the rate of reverse reaction. So the rate of forward reaction is equal to the rate of reverse reaction. Give a reason why the reaction above is homogeneous. Homo means same. Homogeneous means same here. Why is it homogeneous? You can see everything is G, gas. All products and reactants. I wanted to say all reactants and products. All reactants and products are in gas form or gaseous phase. That's what they wanted to say. But the keyword there is to say the reaction, everything in the reaction is in gas, but it's the right. All reactants and products are in gaseous phase. Calculate the initial mass of oxygen if the equilibrium constant Kc is 800 degrees at 6. Now there is our Kc calculation. Now the moment they say it's 8 marks, this one. The moment they do that, what must you do? Go for the rice table. Remember the rice table. What do? You consider what you are given here. It's 4HCl plus oxygen is 2H2O plus 2Cl squared. So let me write this. 4HCl plus oxygen. How many molecules of oxygen is 1? Is 2H2O. So more of it is going, like in the beginning there is less of that, so it's 2H2O, meaning it's moving forward, plus 2Cl2. Am I right? 2Cl2. Everything is gas. so I can forget that. I don't have to put that down for now, but let me just do this for the sake of everything. So everything is a guess. Let's do this so that I can have enough space now for my rice. Alright, then from there, what do? I come in here with my table so that we can see where I'm dividing, what I'm dividing. I don't need to make this smaller. Let's make this long as possible. Okay, make it as long as possible. Let it go down as possible. Then we can have that. We can have that, and that. Okay. Now from there, that's my what? That's my rice. Okay, ratio initial. Please don't leave it as rice. Initial moles, change in mole, equilibrium mole. Don't do that. What I'm doing is in short form. Then this is equilibrium concentration. Equilibrium conc, but don't forget, what is it? C is N over V. Alright, ratio, start there. We've got 4:1, is to 2, is to 2. You can see the numbers 2, 2, 1, and you say 4. Initial moles, that's where it comes. Initial moles. Initially 1 mole of HCl, so I'll have it there. 1 mole, but they were clever to give us an unknown mass of oxygen were mixed. So let's call the moles X. We'll call it X moles. Were mixed, but initially, guys, we haven't formed any product, so it becomes 0 and 0. Now establish the signs. Change in moles. Where is this reaction going? You can see I even made it. Let me make it thicker. It's going this direction. It's going to the right, forward reaction. If it's going in the forward, this is getting negative, this is getting negative. After that one, these are increasing. Are you with me? Now, with that in mind, the change in moles, and then they told us something interesting at equilibrium. Says at equilibrium, 28,4 grams of chlorine was present. So we can now go 28,4 at equilibrium. So I'll come here and say at equilibrium, 28,4 grams of what? Of Cl2. That's what they told us. Am I right? That is happening at what? At equilibrium. So if this is happening at equilibrium, you now know you can find the number of moles at equilibrium. It's grams. Now what is N? Is M over this, right? And we know the M for chlorine is what? Is 35. This is same as saying equal to 28,4 over 35,5 times 2, which is like 71, you know. So when you do that, use your calculator, you can quickly get that. 28.4 over 35.5 times 2, which is 0.4 moles of Cl2, but it's at equilibrium. So you go here, equilibrium, but it's moles. Equilibrium moles, which is here, equilibrium moles. What do you have of what? Equilibrium moles of chlorine. They said 0.4, that calculation. Are you with me? It is 0.4. Then we got this thing like this. We can now establish. How did I move from 0 to 0.4? Obviously this simple becomes 0.4. 0 plus 0.4, 0.4. Ratio, look at it. For every 2, look at the ratio. 2 water, 2 chlorine. 0,4 means also you match. If 2 is to 2 of what? H2O and Cl2. So what about 0,4? It will also be 0,4. Are you getting what I'm trying to arrive at? So here you also have your 0,4. Now that one is easier to establish. What about this one, whereby the other ratio is, you just match, guys. You just match what you're given. Look at water, oxygen is to water. What is the ratio? 1 is to 2, meaning for every 1 of oxygen I get 2 of water. What about 0,4? Yeah, 0,4 of water. It will give me half of oxygen, 0,2, you see. So that I say 0,2 times 2, twice I get that. And I told you the principle of cross multiplying, whereby you say when it's before 0,2, you can make it x here, you cross multiply to say 2 times x, 2x is equal to 1 times 0,4, 0,4. You divide by 2 like this, then you get 0,2. It's up to you, but you can see that it's 1 is to 2, meaning water is more than the what? The oxygen twice. So this one is 0,2. But look at this one, HCl, and this is 4 is to 1, 4 times. So meaning if I know that here it's 0,2 of the oxygen, this is O2 and HCl. So it's 4 is to 1. What about 0,2? You multiply this by 4, it's 0,2 because it's 4 times. You see? So it's more like 0,8 here. Do you see how you use proportion? It's 4 is to that. Okay, you can use 4 is to 2 still, but at the end of the day, you're going to get 0,8. Then you start subtracting 1 minus 0,8, it gives you 0,2 here. X minus 0,2, you get your x minus 0,2. And then here, 0 plus 0,4, you get 0,4. You see? Then, what was the volume? Let's check the volume. They told us 5 dm cubed there. 5 dm cubed container. So we can literally get this volume now to say C is 0.2 over 5, and then x minus 0.2 over 5, 0.4 over 5, and 0.4 over 5. It must be giving us the answers. Okay, let's start with the first one. 0.2 over 5 is what? 0.04. Alright, and then what about 0.4 over 5? 0.08. So here it's 0.04, here it's 0.08, here it's 0.08. That's it. So when we have done this, we have to find out now our Kc expression. So this is still important. Let me calculate my Kc. Is equal to concentration of products. So which one is my products? Guys, you need to know Kc. This is this H2O and Cl2. So I'm gonna have here concentration of H2O. It's 2 of these, so it's squared. Cl2 was squared over concentration of what and concentration of what. Let me check. Over 4 HCl and 1. So HCl here it will be power 4. And what? It's oxygen. Okay. It's power 1. Right? So the question said, calculate the initial mass of this if the equilibrium constant Kc is 800. So they gave us also Kc here. Kc is equal to 800. Very important. So you now equate. So what do you say? You're going to take the values now and say, okay, what is concentration of H2O H2O 0,8, Cl2 0,08. So I'm gonna put these values now. 0,08 squared 0,08 does the same squared over HCl 0,04 here, 0.04 to the power of 4. You see that? And then on this other one it will be what? X minus 0,2 over 5 to the power 1 minus 0,2 over 5. This is just the power is equal to 800. You see now where everything happens. Then you got this, and then it's up to you how you want to do this, but you can cross multiply like this over 1, where that top multiplies that and this top multiplies this, so it will be 800 times that. So I will have 0,08. I don't want to simplify this for now because I can see things, out there lots of things are cancelling. Remember the importance of you doing pure maths here now, because it helps you now. This times what? Times x minus 0,2 over 5 times 800. I just cross multiplied. I took 1. This is times 1. 1 times this. So 1 times that. So nothing changes. Then at this stage, I'm interested in this, so I can divide by 0,04 to the power of 4 times 800. See what I'm doing? So that this is gone. But what you do on the left, do on the right. 0,04 to the power of 4 times 800. Are you with me? Then at that moment, calculator would come handy to say 0,08 squared times 0,08 squared over 0,04 to the power of 4 times 800. 1 over 50, 0,02. So 0.02 is equal to x minus 0.2 over 5. See, simplified it now. They don't give marks mainly for this. Multiply by 5, multiply by 5, do this. 5 times 0,02 is equal to x minus 0.2. Now take this to the other side. It will be what? It will be 5 times 0.02 plus 0.2 is equal to x. So you can conclude now and say 5 times 0.02 plus 0.2. The answer is 0.3. So you've got x being equal to 0,3 moles. Are you with me, guys? So having got x, but what does x mean? You come back here. Okay, what was the question? First, let's ask the question. It says calculate the initial mass of oxygen. Initial mass of oxygen. So initial moles is 0,3. See, initial moles. So already we've got initial moles of oxygen. So you can come here and say initial moles of oxygen, because we made it x, of O2 is equal to 0,3, and then therefore mass of oxygen. You calculate now mass M is equal to N times molar mass. Where am I getting it from? I'm getting it from N is M over M. I see this one, whereby now you multiply by big M, you multiply by big M. So which is equal to, now oxygen O2 is 16 times 2, the big M. Okay, what am I doing here? Let's start by 0.3 times 16 times 2, because it's oxygen. Oxygen is 16, remember. You just have to use your periodic table there, but getting used to that, it is times 16 times 2, and the answer is not 16 comma 2, 16 times 2, the answer is 9,6 grams. Alright, so that is then the answer for that. To say 9.6 grams is the answer for what? For the initial moles. Calculate the initial moles. There. Calculate the initial moles of oxygen. Okay, now stately Chatelier's principle. I've stated this one. You guys need to check in the previous lesson, but you also need to master this. But the key part there, it's a closed system. When a closed system in equilibrium, that's the key word. It must be a closed system in equilibrium, is subjected to a change. Okay, let me state it in words. Chattelier's principle states that when a closed system in equilibrium, or when a system in equilibrium, when a closed system in equilibrium is subjected to a change, the system will readjust itself to establish a new equilibrium by encountering that change. But you can use anything there. The volume of the container is now decreased. What do they mean when they say decrease the volume? You increase the pressure. When the volume gets smaller, pressure gets bigger, while the temperature is kept constant. Very good. How will each of the following be affected? Choose from increase, decrease, or remain the same. Now, value of Kc, no change. Remember, Kc is affected by temperature. Remains same. The mass of the Cl2 in the container. Now, look at this. The mass of the Cl2, meaning what will happen to the Cl2? Obviously, is the gas there which links to the mass. Now, you have to look at the moles. 4 plus 1 to give us 2 plus 2. So how many moles? 5 moles react to give 2 moles of what? Of products. So these are reactants and these are products. So do you see? 5 moles react to give 4 moles, not 2. 4 moles of product, meaning where is the pressure in here? There is more pressure on the left hand side. So here I can come and say left hand side is more pressure. There are more moles, more gases. And then a right hand side is less pressure, less P. If I increase pressure, this reaction, where will it go? It will go from where there is more pressure to where there is less pressure to remove that extra pressure. So it will go forward, meaning it will increase the water as well as the chlorine. So here, what will happen to this? It will increase also. Alright, it will increase because the reaction will move to the product. Explain the answer in 6.5.2 by referring to Chattelier's principle. That's what I already did. Number 1, how many marks is this? 2 marks. So what does Chattelier's principle have to do with that? Okay, you're going to say increase in pressure. Okay, so remember, decrease in volume means increase in pressure. And then you're saying forward reaction is favored. Forward reaction is favored. Increase in pressure occurs. The forward reaction is favored as they are as there is less pressure on the what? On the products. And then according to Chattelier's principle, the reaction will favor the side with the less pressure. Okay, that's what I'm trying to say. Yep. And then more products are formed. I know my writing is terrible, but that's it. Okay, Then let's remove this. Then they say here, the temperature of the container is now increased. The moment you mention temperature, you're affecting Kc. When equilibrium is re-established, okay, the temperature of the container is now increased. When equilibrium is re-established, the value of the Kc is what? The value of the Kc is 450. So what was Kc in the beginning? Kc in the beginning, let's look at this. It was what? The value of Kc was 800, meaning Kc went down. Kc decreased. That 450, it means Kc decreased. Are you with me? Now when Kc decreased, remember, you must always remember what is Kc. Kc is equal to concentration of products over concentration of reactants. So when Kc goes down, it means the products went down and the reactants went up. It means the reverse reaction. When Kc decreases, reverse is favored. But when was it favored? The temperature of the container is now increased. So reversion, so increase temp caused reaction to what? To go backward. Meaning the delta H of this reaction is exothermic. This is an exothermic. In exothermic reactions, it is whereby when the temperature goes up, the reaction goes back because already the reaction is producing heat. Remember, exo meaning this reaction here was already releasing heat. This reaction up here, it was already releasing heat on its own. It was delta H is less than 0 according to what they are telling us. So if it is releasing heat and you increase temperature, you add temp, this reaction will go back now, and when it goes back, Kc will also go down. Okay, so what are they saying? I think I've already explained what they want. Is the heat of the reaction delta H positive or negative? There it is. It is negative. We just started. Explain the answer in question. This by referring to Chatelier's principle. Then you start by saying that. Okay, explain the answer. We're explaining this answer. Why are we saying it's exothermic? And then first one, you're going to say forward reaction is exothermic, meaning it produces heat. Number one. Number two, adding temperature, what is it? Favored the reverse reaction. When you add temperature, it favors the reverse reaction, which is endothermic. Or you can even state, even if you say which is, it says adding the temperature favors the reverse reaction, then you tell us the reverse reaction is endothermic, right? Therefore, according to Chatelier's principle, the increase in temp caused a drop in Kc. Okay, thus anything from here, you'll get your 3 marks. Alright guys, we've come to the end of our session where I took you through it's a 3-part video. Part 1 covers this question, part 2 covers this one and this one, and part 3 covers this question. I hope it will help you or guide you as you do and prepare for your final exams. Don't forget guys, I'm rooting for you, hey, for your final exams. I'm bringing these videos not expecting anything from you but to pass, nothing else. You don't have to do anything, but it is my wish that you pass. But should you do something on the other end, just subscribe. You would have done me a big favor, because it helps me to find out who is watching, who is benefiting. If you don't subscribe, it's a bit tricky for me to identify who am I helping, Subscribe. I took my time to give this to you. As I said, I'm expecting nothing, but if you want to give it a thumbs up, subscribe, share the channel, it means you are also rooting for this channel to be known to lots of people, because quite a number are not yet seeing this channel. But the more you do that, YouTube recognizes that there's quite a number of people watching this. It means I can show to quite a number of people also in the similar grade. Guess what? You are helping that guy there, that girl there, whoever it is. Even those who are going to come later, they will still get hold of this video. Guys, reaching out, remember, is the proof of passion, and I'm rooting for you. All the best in your finals. Give me feedback after you write your final exams. Thank you.